The second biologically important class of compounds is the lipids. Lipids are insoluble in water and other polar substances. That's why this oil floats to the top of the salad dressing. The basis of the structure of most lipids is the fatty acid, a chain of carbon atoms held together by covalent bonds. Those fatty acids having all single covalent bonds are called saturated fatty acids. Other fatty acids contain double covalent bonds and are called unsaturated fatty acids. These unsaturated fats are more reactive, so they break down more easily. In contrast, saturated fats are less reactive and tend to deposit in the arteries. Animals, such as these polar bears, store lipids as fat. While the energy in lipids is not as readily available as the energy in carbohydrates, lipids are able to concentrate much higher amounts. Fat contains twice the energy of the same amount of carbohydrate. During the harsh winter months, when food is scarce, these bears' bodies break down the fat and use the stored energy. Stored lipids are broken down only after an organism has used all its starch and glycogen. Plants also have a lipid energy storage system. They convert excess starch to oils. Some seeds, such as peanuts, yield large quantities of oil when pressed. These oil reserves provide energy to the emerging seedling until it can make its own food. Lipids also have a variety of structural functions. They may serve as insulation, allowing animals such as seals to live in areas of extreme cold, and protecting the internal organs of animals like the camel from the intense heat of the tropical sun. The camel's hump is a large reservoir of fat, not a storage site for water. Lipids may provide padding for vital tissues and organs. Our kidneys are embedded in a thick layer of fat which protects them from sharp blows and damaging jarring. Thick layers of wax form a protective coating on the outer surface of many leaves, protecting them from water loss.